Okay. So, having looked into issues like storage capacity, sizing, etc., etc., now we can look into controls, right. So, control in the basically we need some control. Why? As we have seen, if you recollect, I will just draw it again for you right now. Draw it again for you. We had some resource environment, remember, resource environment, then the system, service system, right, and then I have got the control environment, basically where I want to provide the service, right. Now, this has to be in a controlled manner, this has to have controlled manner. For example, for air conditioning I have got temperature and relative humidity. Now, I will be supplying, supposing it is in a tropical climate, and in summer I will be supplying cool air to the room, which will absorb the heat from the room and then exhaust out. So, in such situation this supply has to be controlled depending upon the situation here, right, depending upon the situation here. I cannot go on just supplying and cooling it as I require, because there is a range, bottom range. So, there is a design range. So, I must get an information from here and control this supply. So, there has to be, so the control system is required in order to ensure that I am supplying or maintaining my system is system is providing the control environment is controlled condition as required, not more, not less. So, this is why we need control system, right. So, if we do not provide control, we might be wasting the resources, right. So, for example, air conditioning running needlessly. Now, my office room, let us say, right, I keep the air conditioning room because it is a small room, that is what is many places we have manual off and control switch. So, I just put it on and do not bother to, even one way is to feel very cold, put it off, or other way, I mean that is also a kind of a control by manual control by myself. I am feeling that it is too cold, so I do not need AC, put it off and so on, or else I can just leave it on all the time. I mean, so if you do not, if you have a control, then resource wastage will be relatively less, resource wastage will be less. So, AC will not be running needlessly, or sometime it may not be meeting the needs or requirement of the needs. It's supposing capacity is there, but supposing the AC is somewhere else, right, and I do not have a control, it does not see my condition. I have a centralized AC, or maybe it is catering to 3-4 rooms, and there's it doesn't, so nobody comes and asks me. In a way, if it is human being, then somebody can ask, are you comfortable? Okay, but if it is not, if you are no human involvement there, automatically it should sense the room temperature and relative humidity, and then put the duct, put the supply on or off. So, if I do not do that, I may not be meeting the requirement all the time, So, this is what it is. Then it will give higher degree of satisfaction, obviously. Psychologically you feel better, you just do not have to do anything, things are under automatic control. So, manual, one is manual off on control system. Now, of course, its extreme case is an intelligent building, where it senses your requirement of all kind, and there is a computer control system which will automatically control. For example, you the many kinds. For example, you enter the room, it senses that a human being is entered through infrared sensor or something of that kind, right, because body temperature is different than the air. So, then immediately it triggers off all the lights on, right. So, such can this is so it is you need some sort of sensing and feedback system. Okay. So, then the controller system would work. Now, it can be automated manual control system, it can be manual control system, right, and manual control system always will be off or on. That is what we call as 2-point off on control system. Manual system will be on simply either off or on. So, we call it 2-point off on control system. Obviously, automated can be mechanical or electronic, whatever it is. So, 2-point off on control system. The other something else is called proportionate control system. Proportionate control system. So, what it will do? It will see proportionately, some proportional way we will see that it will reduce down the supply. If it is cooled too much, or it senses the temperature, and then it will supply proportional to the temperature. You will see that, and there are temperature, etc., etc. So, temperature, humidity, flux, many things it can control in that manner. So, essentially it would be something like this. Ideally, it should be something like this. We have something called a desired value or design value, right. Something called a controlled variable. What is controlled variable? Temperature or relative humidity or lux level. Temperature, relative humidity, lux level, or even it could be noise level in a privacy, office related privacy, because I do not want any noise to come into my place. So, supposing I have sensing devices, there are systems maybe, or if not there would be possibly. So, whatever it is, everything. Fire, we have already talked about automatic detection and extinguishing systems, sprinkler systems which works automatic. So, when you put all of them in a building and make it work through a computerized system, that is an intelligent or smart building. It has come long back, 90s, it is not today's, 90s it was there. The Japanese, they have experimented on some building. In India too, there was a talk of this, or 80s and 90s people talked of this. India Habitat Center is supposed to be intelligent building. I am not sure how much intelligent it is at the moment over the years, but that you have to see, I am not very sure. Similarly, CMC building in Mumbai was supposed to be an intelligent building. So, where the things should be sensed. So, ideally it should be like this. I have one variable, I call it controlled variable, which is temperature, relative humidity, lux level, or whatever you want to control, temperature related to fire and so on. So, this is control variable, internal temperature, one of them example, and it has got a design value or desired value. So, what I should ideally I should be, when 8 o'clock my office starts, this is time, or maybe 9 AM it starts, it should straight away go during the occupied period and comes back to lower level, right, system on for exactly my required time. But if you look at the temperature, it will not be like this. This is ideal scenario. The system has got some inertia. So, the moment you put it on, it will not reach to the or desired value, right, and when you put it off, it will not come back to the same value. So, if somebody has to put in a centralized system, one will have to put it somewhat earlier than this, and system is on up to this time. Then once it has been put off, it would actually reduce down asymptotically towards the ambient situation otherwise. So, system works for a longer period of time, and this is, let us say, this is what we should understand, that it does not work. Now, essential component of such control system will be first of all a feedback. So, you have the control environment, you must have some sensors, there, sensors, control environment, sensors. This we have seen that outside disturbances which will come, for example, outside temperature changes, relative humidity changes and all that. So, these sensors will send the signal, and there will be some valves which will control the flow. The service system is here, then it the flows goes according. So, it will not draw the resources as much as required if the temperature has already come down, or if it is heating, temperature has already gone up, the full heater will not be operating. So, there may be multiple of them. So, controller is the one which senses through the sensors it gets to know about what are the temperature here. The sensors could be whatever we have talked about earlier also. For example, in temperature it could be thermistor, or even bimetallic strip thermometer, which are not, I mean it has to be efficient depending upon what you are looking at, thermistor or thermocouples or whatever it is, some kind of temperature sensing device. It sends the signal to the controller, which actually would, this is essentially this is an electrical signal. So, this controller will send signal and close or open the bulb depending upon the temperature sensed here. If the temperature is much higher than the design value, then it will supply more, and if it has come below the design value, it will supply less. Or if it is 2-point off on control switch, when as soon as it reaches a value, what it will do? It will simply call, okay, put it off automatically. This can be done. This is this modern electronics and electrical systems, they can do it very easily. There is no problem. For example, circuit breakers, as you know, if the current goes high up, automatically it shuts off. So, I mean this controls is a subject by itself. So, therefore, electronic systems or electrical systems, they can help us doing this, and this is what essentially the component of a service system with control. So, you will have sensors, you will have controller, and that controller is connected to their bulbs or switches. Rest of the things are all same. Right. So, 2-point off on control and proportional control, right. Let us see, I will come to this first. Let me go to 2-point off on control. If it is because some definitions are there, I said that there is a desired value, but you can't keep it exactly same at that point. You will have some deviations from that on the plus side and some deviation from that on the minus side. So, this is called operating differential. If you have a 2-point off on control switch, it switches on here. The moment it switches on, it reverses the direction. For example, this temperature was, this is a heating system, let us say, or if my temperature is downward, right, say this is something like 22 degrees centigrade or 22 degrees centigrade, and this I am talking of Indian scenario, 22 degrees centigrade, and this is 28 degrees centigrade, right, higher temperature on the lower side, because my desirable temperature or design temperature is 25 degree for my comfort requirement. Now, if I have 2-point off on control switch, what will happen? As soon as I put it on, it is now at 28 degrees centigrade, it is reached. So, I should put on my system, then only cooling will be done. So, it starts cooling, starts going towards 25 degrees centigrade, but it will not stop, because you have to have an operating differential. You should not put off the system as soon as it goes to 25, because then it will start again heating up quickly. So, you will never reach. So, what you do? You have another 3 degree, because 28 degree you decide that I will start at 28 degree and 22 degree it will put it off. So, what happens is, so it starts cooling, goes up, and at the moment it reaches 22 it puts off, 2-point off on control. So, 28 degree, and this is called operating differential. So, when it comes to the extreme level of operating differential, either it switches off or switches on, depending upon which side of the desired value or design value of the controlled variable you are. If you are on the higher side, that you do not require control, then it will put it off. If you require supply, then it will put it on. And if it is heating system, the temperature will be upward. it could be something, you know, like Western countries, maybe this is 20 or something they want to keep. So, it goes to 20, depends upon how better control you have, 25 degree or plus minus 5 degree or plus minus 3 degrees you want to have. So, 23, right. So, 20 degrees is, so the moment it is at 18 or something like that, or 17, it will start heating, goes to 23, it's so on and so forth. So, this is 2-point open control switch, this 2-point open control switch, right. So, this is system is on for this period of time, you know, it starts here, system is on for this period of time, then system off, during system off time it comes down and then again you start. So, this 2-point open control system. The controller does the job, it just puts it off. You have got thermostats, refrigerator, simple example. So, what it does? It measures the temperature, right. The moment the temperature it has cooled down to a level, it puts it off and again it starts. So, you can do the same thing for all other systems, many other systems you can do the same thing, it puts it on. Heaters, for example, oil cooled heaters these days, which you find, you know, portable heaters, you find that they are with the thermostatic control. So, thermostatic control is simply 2-point open control system. Okay. So, let us look at the next one, 2-point open control system. This system will house a region, an upper limit of design variable and lower limit of the same, that is my control variable actually, temperature. So, this is called operating differential, as I have shown in the diagram. If the temperature is above upper limit, system will be on and starts cooling. In case of cooling scenario, it will remain on till temperature falls below lower limit. When it reaches, when it will switch off, you know, when it switches off, then when temperature goes above upper limit, it will switch on again in case of cooling situation, and it will swing between upper and lower limit, right, upper and lower limit. Then you have got something called proportional control system. So, a proportional control system looks like this. What it does is, this is my control variable, temperature here, temperature in differential, right. So, in case of cooling system, as I gave the same example, this will be 28 degree centigrade and this will be 22 degree centigrade. In case of heating system, it will be 17 to 23, right. So, what will happen when it is 28 degree centigrade in proportional control system, bulb open, 100% bulb will be open. Now, here you are controlling not the off and on, but control is operating throughout the time, right. Control is operating throughout the time. When it is at highest temperature in a cooling system, it will open up the bulb fully, 100%. Now, the moment it comes to 50%, right, 50%, it will correspond to the mean value of my 25 degree centigrade, it should. And when it goes to the cool lower limit 22 degree centigrade, supply will be 0, right. So, it is proportional, it does not put, you know, there it was 2 point, here it is proportional. If it is at highest temperature, so I design it like this, highest temperature, so linear, simply linear, from the 100% at the maximum temperature and 0% at the minimum temperature for a cooling system, and proportionally it will, for example, at midpoint it will be 20%, you know, at midpoint 25 degree centigrade, supply should be 50%. At here the supply would be, bulb will supply, it will control the bulb, maybe the flow it will be controlling. So, it will be possibly 80% or 75% or whatever it is. So, this is called proportional control system, this is called proportional control system, right. So, in proportional control system what will happen? And if it is heating, let us say, so I will start from 17 to 23. When it is 23, it is already sufficiently warm, it puts it off, and then when it is 17, it will be 100%, and at midpoint my desired value of the control variable, it will be at 50%. So, that is how I design it, but there is a problem with this kind of system. What will happen? The system will have a problem that it will always try to, because it is on all the time, it is not off at all. So, it is on all the time. So, what will happen when it is, let us say, in heating system, it's time wise it is on all the time. Now, my temperature in the heating system, let us say this is 20, somewhere here is 28 and here it is 20, 22 or whatever I talked about, 22 or so, right, 22 or so degree centigrade. So, what will happen? It is on all the time. The bulb which is maximum value, right, at 28, but supposing it is at near 22, 23, still there will be some supply. How much will be the supply? Actually 1 degree out of 6, 100% for 6 degree difference. For 1 degree, how much is the percentage? 100 by 6. So, when it is at 23 degrees centigrade, still 16% supply will be there. I mean 84, it will actually continue to supply 16%. Supposing it goes to the coolest point, 25 is my desirable value, and I said 22 is my limit after operating differential is 22. So, when it is 22, it will make it 0, right, but immediately it will go, system is getting perturbations from outside temperature side. The moment it goes to 23, it will supply something like 16%. I mean 1/6 supply will be there, because 6 degree 100%. So, 1 degree means 1/6 of the 100. 1/6 of the 100 is something like 16 point something. So, it will supply, the bulb will operate at 16% supply. If it goes to 2 degree, it will operate at 32% supply and so on. So, this is never off. For a very short period it might be off. The moment it goes to 23, it will supply 16%, but then at 16% supply the rate of cooling will not be as much. So, it might go slightly higher up to 20, 23 and so on and so forth. So, its pattern of rise is something of this kind with time, but it tends to create an offset. You do not get at 25, you will get it, you do not get at 25, you tend to get it at maybe 23 or 24. So, you always get a temperature lower than the design value in case of cooling. In case of heating, it will be above the design value. If the design value was 20, you will tend to, it will offset over a period of time, and you will find there is a constant offset all the time, and it will tend to, it will tend to keep it warmer than what is required. Now, this means wastage of money. This means wastage of money. Your cost, you need 20, you are getting 21, you need 25, you are getting 24 all the time, some 1 degree, whatever, some offset will be there. So, we generally control it. So, proportional control system has a problem, small problem, which is it will try to create an offset, right, on the higher side, right, higher side on the design value. Higher I mean here, not the absolute higher comfort value I am saying, So, in case of heating it will be 1 degree higher maybe, or some degree higher, fraction of a degree higher. In case of cooling it will be fraction of temperature lower. Similarly, for any other thing if you are controlling, it will be of this kind. So, this offset can be minimized or reduced down, right. Actually it will bring in inefficiencies, of the system. So, x is an offset which will remain due to inefficiencies in the system, inefficiencies in the system. The proportional control tends to create an offset. There is something called integral control. Along with the proportional control, then offset can be reduced. So, what it does? It measures the offset over a period of time, right, measures the offset, go on measuring the offset over a period of time, and it actually, this is the proportional, I have got some fixed value plus a kind of a value depending upon where error, depending upon error, how much you are off, right. So, supply is linear. If you look back at this, let us look at back to this. This is linear. So, this is linear with temperature, right. This is supply is linear. So, if I call this supply as defining, this is linear. So, let me redraw this. Let me redraw this here. See, this is linear actually. So, O is the varies from 100% to 0%. O is the value varies from 0 to 100%. O is the output 100% to 0%. So, at E equals to 0, there is a value of A, value of output. It means your supply, cool air supply, that is A, right. Now, if E is plus, error is plus, that means in case of cooling it is actually negative, in case of heating it could be positive, depending upon the sign could be accordingly, plus or minus, O will reduce accordingly. So, Kp is the slope of that line, Kp is the slope of that line. For example, over 600 degree, 100% over 6 degree, for 1 degree it is 16 point, I mean 100 divided by 6, because I said that 22, 28, operating differential is 6 degree. So, this Kp is nothing but the slope of that line, E is the error. So, Kp is the slope of that line. So, Kp is the slope of that line, right. E is the error. If the value Kp is nothing but 100 divided by operating differential, right, 100 divided by, that is the amount of change in the output for unit change in error, unit error, for unit error, which could be positive and negative. So, that is what it is. It would be only 0 when at certain value of error, right, because A minus this would be there. So, it will be 0 and some value it will be 100%. So, we know that actually we can find it out. So, an proportional integral system, I have something else. So, what we do is we measure, we try to find out the E dt, try to find out the error over a period of time, right. Continuously you try to find out E dt, which is the area under this curve, this area, you are trying to find out this area. So, area under, this is the error, offset, error, integrating over the time E dt. So, you try to E dt. So, there is a offset is there. Now, offset might change. How it will change? The error might change, because if you have added an integral control system, it will try to reduce it down. So, this what we are doing is we are integrating it. So, E dt and multiplied by a factor, E dt is the area under that curve. Sorry? Ki is a constant, it will be multiplied, you must multiply depending upon how much you have multiplied. Actually, it should be minus, this total thing should be minus. I mean, depending upon E sign of the E or whatever it is, this should minus and this bring down to the offset should be, output should be as close as possible in such a manner that depending upon the offset. So, Ki is a constant, which would depend upon, basically is a constant that if the error in unit time, is a area under the curve, for unit area under the curve, this should be the adjustment. Ki is the adjustment for unit area under the control variable and time curve, area under the control variable and time curve. So, for unit area over a period of time, unit area it tries to. So, K's are gain constant, these are called gain constant. So, this is a gain constant which is nothing but the slope of that line. This is another gain constant, Ki is another gain constant for integral control, right. This is Kp for P subscript for proportional control, I for integral control. So, that is what is done, and this is basically our understanding. So, if my point here is to people, if somebody is saying they are providing you a controller in a service system, you ask them what kind of controller it is. If it is of course computer controlled, that would be far better, that would be far better, obviously that would be far better, intelligent system. So, it actually the microprocessor and things like that, I mean the computer would control it. So, controlling digitally is much better system. So, you have a total control room where everything is controlled together, all variables are controlled together. But obviously, now you understand, and proportional integral control system is better than simply proportional control, and far better than 2-point often control switch. So, if you are installing something, you got to know this kind of this knowledge should be available to you. The lastly, the sensor locations. Now, sensors should be located in such places where this is your inlet point, this is your outlet point. So, sensors should be located at points like this is your control environment. You should have sufficient sensors. So, typically A, B, C are the sensor location. At the entry point you have something, and at the near the exit line somewhere you should have a sensing device, and somewhere in between you might have a sensing device as well, right. So, that is what it is. So, that is what it is. So, this is the general discussion on control system. I would have one lecture, we will devote one lecture to intelligent building sometime later on, right, some intelligent building sometime later on, and you can understand that your initial investment may be somewhat higher, particularly in functional building, because the cost of controls are very much there. But if it is a large functional building, it may be worthwhile, because it would actually give you better comfort and also reduction in cost. For example, energy cost, right. In an air conditioning system, energy cost, wastage would not be there. So, that is about the control system and general discussion on services.